Hey everybody, welcome to today's Kubernetes Master Class, bringing Istio to production. Really happy to have you all on the line. I just want to mention as people are joining that the session is being recorded and you will receive the recording and the slides after the presentation. So if you need to leave for whatever reason, you can't stay for the whole thing, don't worry, you'll be able to review what you missed and go back over parts of the presentation at your leisure afterward. We have about 90 minutes scheduled and a lot of great material to go through, so let's go ahead and jump in. As a way of introduction, my name is Matthew Shear. I'm a marketing manager here at Rancher. I host these training sessions and also our intro to Kubernetes and Rancher sessions on Thursday. So we have just a ton on the calendar for you to learn from. And our presenter on the line is Braden Wright, Senior Cloud Architect at Root Level Technology. Really glad to have you today, Braden. Are you there? Are you online?
Yep, definitely.
All
Thanks,
right,
yeah, it's good
awesome.
to be here.
Yeah, and I also want to mention, not on the slides, but we do also have Robert Bailey, a VP of Application Development, who's going to be helping out with questions as well. So Robert, really glad that you're here too. Thank you so much.
No, absolutely glad to be here.
All right, good crew. So a couple of housekeeping items before we dive in. We try to keep this to 40, 45 minutes. We're going to go long today. It's going to be closer to 90 most likely. And that's just because it's a very in-depth topic and there's a lot to go through. And we try not to leave before every question is answered. So please do ask your questions early and often. If for whatever reason you want it to be private, just mark it as such. Otherwise, we will consider it fair game and answer it for the benefit of everyone. So just use the chat question feature in GoToWebinar in order to ask your questions, and we will take moments to pause and answer them. This session, as I mentioned, is being recorded. We post everything on YouTube, so if you want to look for our past sessions, you want to look for this one, it'll be there, youtube.com/c/rancher. You can find all of our online meetups, trainings, and masterclasses there. If you also want to get connected to our community, hear about other announcements, this is the place to go, slack.rancher.io. It's totally free to join. This session and others are announced at a Pound Masterclass, the Masterclass channel. We post files and other artifacts from the class, from the session. So if you want to find them, you can find them there. And we have a lot of really cool sessions coming up on the calendar for June and into July. So we'll be covering, securing Kubernetes in production. We'll go over different aspects of Kubernetes monitoring and storage too. So it's a lot of good stuff. All of these sessions are totally free to join. Join as many as you want. You can review them later as well if you can't make the one that you signed up for. So with all that out of the way, we can jump into the meat of the material, and I'm going to pass this session over to Braden. So I'm going to make you the presenter, sir.
Great, thanks. All right, and hopefully everyone can see a slide deck.
Yep, you're good to go.
Great. So my name's Braden, as he talked about. I'm a cloud architect over at Root Level Technology. I've been using Kubernetes in production for about 2 years here, and I've been using Istio, trying to get it ready for production since the end of last year. And currently we do have some stuff running in production, so that's nice. So as far as this is going to go, if anyone has questions, feel free to ask them during. I'm going to try to pause every so often and kind of take them in. I know if we go too far down the rabbit hole without answering some things that people might get lost. But there is also going to be some time for questions at the end. So, if it's something relevant now, ask it. If it's not, then write it down and ask me later if you don't mind. So in this case, we're going to be doing some live demos. I was going to record the demos so that I had a backup in case there was a problem. But as I was going through it, most of it's just showing that an endpoint works successful. So if the endpoint doesn't work, I'll be sure to post and README on GitHub about what happened and how I was able to fix it. So without further ado, we'll kind of get into it. So Istio, everyone's heard about Istio, and that's the greatest thing since sliced bread. But when do you adopt it? Is it too early? Is now the time? Those types of questions can kind of be hard to answer some of the time. So let's say that for just a talking point, that all of our developers are crazy about microservices. They've heard that they're the greatest thing around, and so they tell us that they need to start using microservices. So we just blindly accept this, and like any good DevOps team would, and we're like, sure, we'll throw this in production tomorrow. So some of you come from a monolithic application to a actual, sorry, slide isn't moving. Okay, some people who actually come from a monolithic application to microservices probably have experienced a lot of this stuff. At the beginning, when you just have one machine, it's pretty easy to deal with. If you need to look at logs, you hop on the box. If you need to know where slowness is, there's only one application to look at. So as you start growing into microservices, though, things start to become hard. All of your information is dispersed all over, so you better have some good logging and monitoring tools and things of that nature. And then as you start to have this mesh, like finding out where problems are going on and what's happening can be really hard, getting that visibility. So common things are like, maybe a database is out, maybe your auth service is being really slow to respond, and how is that going to affect the rest of the application in this situation? So service meshes were created to answer some of these problems or questions. Specifically what they are is, in the left here, you can see there's no service mesh, and then on the right, there is a service mesh. So the difference would be that on the left, you've got a Python application with a product page, and the product page talks directly to the Java application review one, and same with everywhere else in the application. We'll call those Docker images, so one Docker image is talking directly to the next Docker image. On the right, in the service mesh world, what we're doing is we're simply adding this black box here, which in Istio is Envoy, and it's running as a sidecar proxy, is what they're called. And the idea is that as things need to talk, rather than the Docker image from the product page talking directly to reviews, it'll go to its proxy, and then its proxy will talk to the proxy for the review service, and then basically the only thing that talks directly to your service is your sidecar proxy, and really sidecar proxies are talking to other sidecar proxies. So laying up this kind of setup gives you a lot of control and gives you the ability to, oops, sorry, finding my pointer. So kind of the way I think of it is it's almost like, you have a house and you built a giant wall around it with a castle and a guard, and you've now got a gate, and that gate or gatekeeper is going to be able to look and inspect everything coming through. So, you can start to find out things like, is this person a bad actor? Are they just, hitting us way too much where we can't handle it? You can start to make different rules and definitions and enforce those. And in this case, you're able to enforce them at a system level with a policy that cuts across in your service mesh. Back in the day, you would have to actually write this type of stuff into your application code or have it live somewhere else. And if you have a monolith, again, maybe that's not bad, writing your own rate limiting. But as you start to have, hundreds of services and they're being run in different languages, you'll have to start building out the functionality in multiple frameworks and languages. It can just become a mess. So really the proper place to deal with it is giving you back control of your network. So right now there's a few different service meshes out there. There's actually a lot more than I'm showing, but these are some of the big ones. So Istio and Envoy is the one that everyone's heard of. Envoy came out of Lyft. It's been 1.0 since 2016, so it's very stable and has been out there a while, even though Istio's newer. The other one, Linkerd was a big one that was out there for a while. The same company is pushing Conduit. They rewrote it so that it's lighter packaged and to compete with some of the things that Istio is doing. And to be fair too, Istio is not doing everything the best way. There's different service meshes succeed in different areas. So Council is good if you have a lot of VMs and stuff outside of Kubernetes. Istio does a great job inside Kubernetes, and it's a first citizen, and you can use it outside of that, which helps you really bridge the gap. One example of something that they don't do very good would be how they deploy configuration to the Envoy sidecar, which I'll talk about on the next slide here. So Istio, service meshes, what do they do? You can look up a 101 or go to their website and find out a bunch of stuff. I listed a few things real quick. They'll help you with reliability. Observability is a big thing, giving you access to open tracing and monitoring. Some things like actually routing and controlling that, so you can actually route based on paths as you would anywhere else. You can also look into headers to route. They give you some cool things like mutual TLS, where you can start to enable encryption between your services inside the cluster. So yeah, they give you a lot of cool stuff to work with. Look up more if you're interested, but I just don't want to spend too much time on it. Anyone have any questions right now before I kind of dive in? So the one thing I'll say about Istio is the way Istio works is there's a sidecar proxy up here by the service, and there's three main components in the control plane that are shown here. Pilot's actually the one that publishes the configuration, and as I was talking about, they actually don't do a great job because they publish every configuration to every sidecar proxy. So as your cluster grows, it's got to publish a lot of information about a lot of different services, and that's just really not scalable. There's other service meshes that actually do take a more targeted approach there. And I know there's been some talk about having that be brought into Kubernetes and Istio. Oh, right. So in this case, we were starting to evaluate Istio, and we were trying to figure out, what we might like to use. For us, a lot of it was some of the security and observability things, specifically like the ability to integrate with auth-c is pretty cool. You can get an authorization layer that cuts across your service, and then open tracing and Prometheus, getting extra stats out of that. You actually will get a stat for every single call that's made. The information will be reported back to Mixer, and they'll be saved so that you can get it. So for us, it was kind of getting a little more insight into our cluster, and then having a foundation that we can grow on. So the most important thing to start with was we didn't want to lose any features. We were using traffic as an ingress, and doing so, we were able to have public and private endpoints. Things could talk inside the cluster. The private endpoint was only accessible via VPN. Ingresses, their IP addresses would be found and synced to an external DNS source. And we had SSL at the edge via LetsEncrypt. So those were all things that we wanted. Some bonuses for us would be the ability to control egress, and then, as I was mentioning, the observability. All right. Istio itself, this was a question that came through, actually runs as a sidecar. So it runs in a coupled way because every container that you have can run a sidecar that can control what gets to it. But as we'll discuss as we get further down the line, to actually get into the cluster, there's other Istio pods running, and Istio talks to Istio in that case, from a gateway into a service pod. Typically at this point, I'm installing Istio once per cluster. So we're starting with a gateway that's in a specific namespace and leveraging that across the whole cluster. If specific services need other gateways, we get into that stuff. So the first thing that we ran across while using Istio was something I thought was going to be really simple, was the install. So if you just want to get started with it, GKE's got a checkbox, and just check that box, boom, off to the races, nothing else to do. So that's really nice, but at the same time, Istio has a lot of features and there's a lot of granularity to it. I mean, just looking at all the subcharts will kind of show you that if you take a look at the Helm chart. So for us, we decided to use Helm. Helm gives us granularity and gives you the ability to set specific values and things that you want. You'll see throughout this demo that we're going to be leveraging it a lot by turning on and turning off different features so that by the end of this, we've got a full-fledged Istio system that can be a replacement for traffic. A couple of the things though, if you're not using Helm, definitely I would recommend it. It's great for templating, dependency management. It gives you some lifecycle hooks, but yeah, go look that up. It's a great tool. So if you are using Helm, you're probably pretty familiar with the public Helm repo. And if you install something from stable, there's a few things that I at least expect. And one of them is that if I install a chart today, if I install that same chart in a month, it should work. Unfortunately, that wasn't the case with the Helm chart for Istio. So there were a couple of things that we had to do to make it reproducible. The first one was the Docker image actually gets updated. So the Docker image that they are using, they actually pull from a common tag that's updated nightly. So it ends up that it's a tag called master latest daily. And so what happens is, they publish a new image, you go to install it, your node doesn't have that image, it downloads it, it's a different one, and it breaks your chart. So in order to kind of solve this problem, what I was able to do was we could go and look at an existing pod that's running, which I'll show you exactly how you can get to this information in the demo. And then we could actually look up the master latest daily tag. And let's see here. We should be able to do that right over here. So jumping. All right, so like if you actually just pull up the Google repository, and you can get this from describing a pod, you can see that there's the master latest daily tag. I basically start by using the master latest daily tag, run it, make sure everything's good, and then once I am okay with it, I come over here and I look at what the tag is that's not going to be updated and set our values to that. So if you look over here, we went ahead and set a global tag to that master branch, and that'll ensure that we're going to use the same image every time. The other thing is that typically I would just use a public Helm repo and just do Helm install, and everything works great. Istio has another thing where they don't seem like they're bumping their bug versions. So if you go up to their site, they actually recommend that you just use their releases to download things. We can go ahead and, oops, sorry. So we can go ahead over here, and they've got releases that you can just download and use. So the funny thing though is when you download this Istio 1.1.7 and you explode the tar and you go ahead and look over here at the code, the actual chart.yaml that they have, they're not bumping the version there. So by not bumping the version there, you're actually getting a different version than you expect all the time, and it leads to, yeah, you're not having a stable chart that you can depend on. So in order to solve that problem, what we did is we went ahead and pinned the version in our requirements. You can see here it's just 1.1.1. And by pinning it in our requirements, .yaml here to be a file location, we're actually just pointing to the location that we downloaded from a git clone. And in this case, I checked out a specific SHA and kept track of it, or create a branch so that people would know. I did put in a setup file the exact SHA I checked out, so if people want to try to run this on their own later, they'd be able to do that. All right, so now we actually have Istio installed, and what's next? So next is there's a little prereq work that we want to do. I wanted to start from pretty much a clean place and make it so that other people could use it. So for infrastructure as code, I personally use Terraform. We went ahead and in Terraform, the main things we're doing is setting up a GKE cluster. We're then creating some IAM permissions to be a DNS admin, and basically creating secrets for that that'll be leveraged later, which I'll explain. And then we're setting up some namespaces. We did a few things outside of Terraform, and specifically that was enabling some APIs in GCP that's needed. We created a DNS domain and actually set up the name servers so that that would be publicly accessible. And then we created a VPN. Outside of that, everything's just been done in Terraform or in Kubernetes. So if I look at the code real quick for a second here for Terraform, I'll kind of give people a brief overview. So the first thing we're doing is we're setting up a GKE cluster. I tried to keep it pretty brief. You can do things with private clusters. You can do things with actually like setting your IPs so that they're known and etc. But we just did a basic install. So this will create a cluster with a small node pool. And then after it gets created, we're going to go ahead and initialize Tiller so that Helm will work. And that's pretty much all that's being done here. If you take a look over at the Kubernetes namespaces, the big thing to call out here would be that we're setting a label called Istio injection to enabled, and that's going to be for our app namespace. It's going to be called PRD-app. So that'll set it up so anything that gets installed into that namespace will automatically get that sidecar proxy for the application in their pod. These other systems, services, they won't, so you would have to specifically install that sidecar if you wanted it. So the one nice thing is it's hard sometimes to get Kubernetes or Terraform to actually set up a GKE cluster and then configure it and create secrets in one run. But here's an example if anyone needs to do that. So by using a provider like this, you're actually able to just grab the endpoint from the GKE cluster you used, and you can also grab a certificate so that you're an authorized person. Typically in Terraform, I would not put a provider inside a module, but this is one case where I've actually, when I use modules, put it inside the module and it's worked fine. It doesn't cause issues with destroy or anything. So it's kind of an anti-pattern in my opinion, but at the same time, something to be aware of because yeah, it ends up working out well in this case. So let's go ahead and actually run the Terraform code and see what happens. I've actually already created some stuff. So I actually already created the GKE cluster because I didn't want to wait 15 minutes for that. So yeah. So in this case, as we're running Terraform, we'll see that it wants to create the 3 different namespaces we talked about. The Istio system, oh, I lie, I didn't delete the 3rd one, so it won't create that one because the app one already exists. And then it's also going to create 2 secrets for DNS. All right, and that's done. So now let's go ahead and all right, so now that we've got Terraform set up, we can kind of start to install and use Istio, but we got to do a little talking about some naming and conventions there. So if you're coming from the Kubernetes world and you want to expose something outside of the cluster, your main option is ingress. There's the option of using a service load balancer if for some reason the ingress you're using won't work, and that was the way to do it beforehand, but at this point, you're going to shoot for an ingress. So Istio did have ingresses for a little while, but they bailed on them for what they call virtual services and gateways. And they're breaking it into 2 different pieces, and they're also enabling a lot of extra features and possibilities there. So the virtual service is specifically working at layer 7. It's where you can do a lot of your fancy magic with like your timeouts and injecting faults and your routing rules and things like that. So you can route on path or host name, or you can even look at headers. Another cool thing that you can do is you can actually do SSL pass-through. So if you have SSL certs running on an Nginx pod inside your container, you can use SNI, server name indication, and that'll allow you to specify the name that's inside the cert, and you can actually connect out. And yeah, it ends up working really nice so that you can reuse ports, because otherwise the only way you have to route is based off of a port and you can't reuse them because they would collide. So this ends up working out great for those type of situations. Yeah, look into virtual services. There's a lot more that you can do with them, but the basic idea is that you have a pod already has a service that's been attached to it, and your virtual service then does a match of some kind and points to the pod. It's pointing to it off of the fully qualified service discovery name. So the svc.cluster.local is a pretty common thing that you'll see in Kubernetes. The match on authority here, authority is actually the host name. So yeah, that was something that wasn't obvious in the documentation, but works great once you find it. So here is an example of a couple of virtual services, and set this up to call out a specific situation. So basically, we've got one virtual service on the left, I'll call it A, and one virtual service on the right, I'll call it B. And technically, these come from two different charts, so this full name here is going to be different for them. They're two different services. And what happens here is if you have two different virtual services or microservices running and you want to use a common host name but route based on their path, then the use case we had was we wanted everything to default to go to A, this DS front end, and we wanted just one path of aggregator to actually go to the second service. So if you actually load this all up in one virtual service, the order that it goes through and matches is respected, and it's a first match, first win policy. The problem becomes if these are actually installed in separate charts or from separate locations, then because these are different resources, the order is no longer respected in any way. You don't know if A got loaded first or if B did. So you have to actually write a negative regex to say, anything that is not aggregator goes here, anything that is aggregator goes to B. It's definitely a little annoying, and I know that there's been some discussions about the fact that at least having some level of precedence would be good, so maybe it scans over the list, and if you don't have a path, that would be the more generic, and then after that, something with a path would override that. So I don't think there's anything in the works where it's going to be out soon, but it is a problem that's been discussed. So another thing that commonly wants to be done is people commonly want to control their routing. So for maybe A/B testing, maybe for a canary deploy, maybe to roll it out to an internal user to test. Basically how this works is you just set up a subset here in your destination rule and give it a name. And then in the destination rule to the right here, there's actually an array of subsets. And then you can just set labels. So in this case, subset version 1 is going to look for pods with a label version :v1, and subset v2 is going to look for things with the label version :v2. You can also start to put weights and routing rules and other things in here to control so that, it's not just round robin. Anyone have any questions about virtual services at this point? I'm just going to pause and kind of look at the chat for a second here. And you actually, I'll show you here, but you're actually going to be defining the virtual services and the gateways and stuff like that yourself. So I've got a code demo and I can kind of show you those details here shortly. Let's see. Okay. That looks to be it right now. Oops. All right, so, and Robert, as this is going on, if there's anything specific that I should answer from the questions over on the side, just ping me direct and I'll take a look at those. I think you've been doing that a few times, so thank you. All right, so next is virtual services and gateways. So gateways are, rather than being your layer 7, this is more your layer 3. They're pretty basic what you're going to set up. You're going to specify some information about what ports you want to expose. When you do set up a gateway, there's an associated service and there's an associated pod. So those, will get created automatically by the chart for you. And we'll go through how you find those, but there will be a selector on the gateway that finds the service, and then the service finds the pod based off of labels and selectors like it will anywhere else. The other things that you'll set up there is your TLS if you want to use it, say where your key lives, and that'll allow you to load those things at time that the pod boots, and then you can also turn on things like HTTP redirect. So once you have a virtual service and you have a gateway, the idea is that you can attach the virtual service to the gateway, and that would take it from only being accessible inside the cluster and make it accessible outside of the cluster. So in this case, all you have to do is actually specify a gateway on the virtual service. It's pretty easy, and it links it all together. And now you've got a publicly exposed service. So let's actually take a look at this and try to set some of it up. So the first thing, let me minimize this here. All right, so I in the top of the repo, I made a little script here to kind of keep track of everything that we're doing. So anyone who wants to follow along later can do so. And yeah, so the first thing we're going to do is the Istio init chart here. This actually is in charge of, sorry, that's the wrong directory. I have to run it from the actual charts directory, which is in the script. So this is going to actually just download from the location. We talked about in this case for that we're actually pointing to the local file location. So if you look at the requirements.yaml, you'll see that that comes from there. And so this is really just going to install CRDs for Istio so that, yeah, then Istio can be installed and use them. There are some other charts that actually use like lifecycle hooks so that it's kind of all part of the same install. They decided in this case to separate it out. Not sure why, but really doesn't make too much of a difference as long as you don't have to update your CRDs very often. You just have to make sure if you pull in a change, you do. So now that we've got these running, we can go ahead and install Istio. Before we do that, let's make sure that all the CRD is actually installed properly. So we should have 28 of them, and great, we do. And if you want to actually see more of what they are, there you go. So we've got things for like cluster issuer, which is a cert manager thing, which we'll be using later. Here's Istio gateways, etc., etc. So let's go ahead and actually install Istio now. We're going to install Istio with just a single public gateway. And as this actually installs and sets up, I'll jump over and show you some of the code here. So in Istio, the first thing we're going to do is start with this O3 values where we're setting up a public gateway, like I said. So first thing we do is we take the gateway that they give us by default and we're turning it off. Some people might decide to use it if you're just trying it out. Not bad to use the default one, but it only gives you one gateway. So if you want more, it makes sense to just kind of name them and control them yourself. So this public gateway is enabled. And then some of the things to call out would be this label here of Istio Gateway Public. That'll come into factor of how they find each other. And then this service is actually a load balancer type. So the service it creates that the pod talks to will be a load balancer. By default, it's going to be a publicly available load balancer. The external traffic policy here is something to be aware of. So basically what this is as it comes through the service load balancer, you have a choice to either not preserve the client IP and get as good of load balancing possible, or there's a chance that setting this to local may affect the load balancing algorithm a little bit. They make a quick note of it. It sounds something that's more hypothetical than actually been observed in production. I haven't seen any issues with it and like couldn't find any actual issues in GitHub about it that were, recent. So, but it is something to be aware of. For us though, we really needed to have our client IP address in our Nginx logs. So it was something that we were going to test it, but went forward with. So this is pretty much all the install as we talked about. We're actually setting the tag. We're setting the log level to error because there's been some problems with previous issues of Istio where they would just start throwing debug errors and they would just fill up our logs like crazy. And obviously they cost a lot of money and it made it really hard, just to look at the Istio gateway and know what was going on because there was just tons of information. So you had to use a tool and start to filter. At the top here, you'll see a few variables that I actually set up from like this LetsEncrypt area down to HTTP redirect. And then here as well, you can see that we can control what features are going to be installed. So in this case, we're not using a cert manager, but we wanted Grafana and a few pieces like that. So let's see here. Hopefully this install is done. Great. So you can see it installs a lot of things. Let's see, most of these you won't care about too much. Here's a gateway. So there's one Istio public gateway. Here's some services. So it makes an actual service for the gateway that we were talking about. Pilot, the service specifically isn't super I haven't seen issues with very often, but I've seen issues with the pods before where on certain versions they just wouldn't start. The other one that we've seen issues with was the sidecar injector. That's kind of what led us to starting to pin a lot of these versions. So let's see here. All right, so let's go ahead and actually take a look at the gateway that was created for a second here. So yeah, it's, as I said, the gateways themselves are pretty simple. We put a host name, so if the host name doesn't match, then this gateway won't serve it. There's an Istio selector, which is going to match a label on the service. So that's kind of how the gateway finds the service. And then we're specifying our port, and in this case, we don't have any TLS, and we're not redirecting to it. The next thing we would look at would be the service. And so if we do that, we can go ahead and see here that it has got an external public IP for us. So this will say pending until the actual service load balancer gets created for you. And let's go ahead and actually describe this, and we can find that label and make sure that everything would work as we expected. So here's the label that we were talking about, Istio equals gateway public. You can see it kind of does some formatting on it, which is a little weird, but yeah, it's going to work fine. So at this point, now that we have Istio up, let's install an application. This is just a really simple PHP application that hits an API endpoint. So just to kind of give an example of something using a public ingress, or sorry, a public gateway and virtual service. So let's see here. So in this case, you can see that there's actually 2 of 2 already. The application only has 1 container in the pod. So if we go ahead and describe that pod, you'll see that the other one running is actually the Istio sidecar proxy. No, I'm sorry, I typed the wrong system there. So if we look at the right namespace, what are you doing? All right, well, let's find out what namespace that installed in. Oh, it's in prod app, I'm sorry, not prod system. All right, so there we go. Okay, so if we look here, as I said, here's the Istio proxy. So everything's running, it's looking good. In this case, it's running and it's ready, so we should be all set. So at this point, what we need to do is we need to have a DNS record to actually get to this service. So if we go ahead and take a look here, we can describe our service and find out the IP of this. Whoops. All right, so now that we have an IP, I'm just going to use my local host file to set up an address right now, and we'll find a better way to deal with this problem here shortly. So in this case, I'm going to be routing to this my app, which I had set to 1.1.1. We'll go ahead and put the new IP address in and copy the URL, and fingers crossed, let's see what happens. All right. All right, so you can see we're not secure. We're able to get to a page that says server running. There's actually also an index.php page, which will reach out to an external API. And great, that worked too. So you can see that we actually get information coming back, specifically a quote here in a JSON. Let's see here. So at this point, yeah, we have a successful public gateway. We can get to it, and everything's looking good. So let's go back to the slides here and see what we got next.
We got a couple of questions that came in, Braden.
It's a good time
I mean,
to pause. You want to just read them, or?
Yeah, so I think it's Gahadi asks, can you put an Nginx ingress in front of a gateway? The L7 ingress?
I mean, you definitely could because everything's routing, so it'd just be pods. I guess I'm not sure exactly what the use case would be there. Uh, yeah, and by doing so, you would definitely lose some of the features because you would have to go through that Nginx ingress, and it would be kind of limited to the features on the ingress that it had. So I guess I've seen people, like I mentioned, use Nginx like behind the gateway and virtual service for like pass-through TLS, but I haven't actually seen people put Nginx in front of a gateway.
Right. And Haywood said they've experienced performance issues with Istio's bundled Prometheus when running a large number of microservices. And how do you deal with that in production? And have you seen that?
Let's table that one, just because we've got some monitoring stuff to talk about later. But yeah, performance is definitely something to worry about.
And let's see, we had Robert asked, with weights, are you guaranteed session infinity?
I'm sorry, with what?
He said
With
with weights? Yeah, are you guaranteed the session affinity?
In general, I don't believe you are. I actually haven't. I dealt with session affinity and traffic. I haven't looked into it in too much detail in Istio, but my understanding is that they do have those capabilities to support that, but that you would have to actually do some configuration to make that happen.
All right. And Sten, he says, in a bare metal environment where they have AWS ELB isn't an option, does Istio provide a way to handle layer 2 routing?
So it'll still deal with the layer 2 routing, but it's up to you to figure out how to bridge the gap between the rest of your services in your Kubernetes cluster. So commonly a thing that'll happen is that rather than using a service type load balancer, because those aren't actually available in bare metal, or they're not available in Rancher either, would be another situation. So in those scenarios, you basically could set it up as a node port or a cluster IP, and then you could set up your own type of routing to get to that. So like set up HA proxy on the outside, set up some routing rules of your own, set up a jump box, something of that nature. The thing that becomes a little weird there though is as gateways change and come up and different pods come up, they normally get random IPs from blocks. So then, your load balancer has issues there. You can start to hard code your IPs, but I don't know, you're starting to get into a little bit of a hairy situation in my mind when you're starting to hard code a bunch of IPs because, yeah, of how that scales. But since there's a service around it's talking to a bunch of pods behind, it is a viable solution.
Okay. Now, can you bind two virtual services in different namespaces to one in the same gateway?
Yes, you can. So, and that's actually what we're going to be doing in our demo here as we keep going through, but I can show you real quick actually that if we go and look at, here's my app, and let's go ahead and look at the virtual service that we created. So as we were saying, we're doing a match on a host name, which is a variable that we're supplying, and we're supplying a DNS suffix. The values for these things are up here. So here's the suffixes it's using. And then if you look here, the gateway, I don't know how great the documentation is on this. I actually found this in an issue, but you can put the namespace and then a / and then the gateway name you want. So all of our gateways are actually running in the Istio namespace, and pretty much everything associated with Istio, like as we get into some other components, are running there too. And then, yeah, but it is the case that we'll have virtual services that live with the microservice like this, and yeah, this gets installed into the namespace of the application. So like if we do
And have you run into any performance? Have you run into any performance issues with Envoy, especially as it intercepts all the traffic? Is overhead something to consider?
I haven't like specifically. I think some of that's going to depend on your use case, because certain use cases, are going to be a little more heavy than others. The system that I've been setting up, it's been for some PHP applications, so they haven't been too load heavy, and I think the sidecar's been able to handle it well. To that type of information though, like I would say if you have a specific use case, probably just look into it and do a lot of testing, a lot of load testing. But they have been out there since, like, Envoy's been out there since 2006 or whatever. So it's been out there a long time. And it's a pretty stable product. It's with IBM and Google and everyone else behind it, there's a good chance somebody else has run into your problem.
Awesome. And then one last question from Ramandeep. Says, is it possible to add a service name alias just like in Docker using Istio?
I guess I don't know what they mean by a service name alias. A service will automatically get a name based on, it has a short version that's inside the cluster and a long version that's outside. Now you can set up multiple virtual services. So if you want like an alias and to be able to route by multiple names, the list of arrays on the actual Istio gateway that you put, yeah, you can keep adding to that array so that there's more than one. And then similarly, like with a virtual service, you can either add more than one or set up multiple virtual services. So let's see here. So like here in the gateway, we're just listing the host. So if you wanted it to be able to route for more than one host, you just have to make sure that's in there. And then in the virtual service, the only place the host is coming in is on this authority match. So as long as you set things up, you could definitely have more than one. I hope I answered that question right. Sorry.
I think here's one more, if you don't mind. We'll do this one more, and then we'll let you continue. So this is from Rodrigo. When using waits and sticky sessions, is it possible to deploy a new deployment version but maintain all current sessions reaching to the previous version?
Yeah, you should be able to pull that off. Again, it's going to be in the configuration details, but yeah, that would be doable. All right, let's see here. So
yeah, some good questions. I'll let you get back to it, man.
Yeah, definitely keep them coming. I'm kind of focused in here, so I appreciate you bringing those up. So now that we've got a single gateway, this picture I'm actually showing, trying to show all the components involved. So on the left here is what we've currently set up. We've got our gateway, our virtual service, and pods and services. On the right, it's pretty much just a mirror image of it. You can tell that the names are different. Some of the DNS entries are different. It's got an int-example.io instead of example.io. But really the main thing is that this connection from outside is only available through a VPN. It's going to be over a private line. So let's go ahead and look at the code again for this one. All right. All right, so as this installs, I'll show you the values file yet again. So in this case, we're installing values 4. So the top section is all the same. I didn't change anything in the public gateway. But if you scroll down a little bit further, now there's another object in that list for a private gateway. Again, it's enabled. Really, the only things that are different is you have to name it differently so that the gateway can find a different label. Otherwise, you'd be routing to the wrong pod sometimes. And then if you go down here, there's a service annotation, and different cloud providers have different annotations, but this annotation will say, hey, take that default public load balancer and make it a private load balancer. So let's go ahead and see if this finished running yet. Okay, so it looks like it finished, and let's snoop around here. So if we look, we should now have a public and a private gateway. So let's see here. Here's our services. So we have a public and a private service now. Here's our deployment. That'll be our pod. We've got now we've got a private guy that's only 2 seconds old. And here's our gateway. So we now have a private gateway as well. I'm not going to really show the gateway because the labels and everything are pretty much just the same as what was going on before. But one thing that we'll want to do is we'll want to make sure that we actually have a private IP address. So let's go ahead and look at the service, and yeah, you can see here we've got a 10.28.0.55. So let's go ahead and make sure that this is routable real quick, and we'll try to get to it. All right, so here's a few things I've set up. Let's see if we can go ahead and all right, and server could not, oh, I don't think this one was in that host file. Sorry about that. All right, let's see if that'll take care of it. Great. So yeah, now we're able to get to Prometheus, and of course, as we talked about, tons of metrics. You can start to get different counts on here, and yeah, you can scroll through this in your own time, but there is a lot of information to dig into. And let's see, so I said that this was only available over a VPN. So here's the VPN that I've been connected to. So let's go ahead and do. One of the next things that we're going to do is we're going to set up an external DNS. And the idea of this is that we don't really want to be setting up our host file. And as later things are going to use DNS challenges for SSL, we're actually going to need that to be publicly accessible. So there's an external DNS chart, and basically what it does is it searches Kubernetes resources and then publishes those to an external cloud provider. So in our case, we're just publishing to Cloud DNS. You can publish to Route 53, you can publish to Cloudflare. There's a bunch of supported ways. Let's see. So normally how a external DNS chart works is it works great. Ingresses, services, it scans them, finds their IP, looks at the host name attached to it, and publishes that. We've got kind of a weird situation where there's still an open bug for gateways. And what happens here is that you actually have to have an install per gateway, because every IP that you, sorry, not per gateway, but per gateway pod. It's every IP that you have that you want to publish, you'll end up needing a separate chart install for. In the other situations with ingresses and services, one install will take care of both of them. And let me kind of show you a little bit of that detail and why that's the case here. I did go ahead and make sure to link the current open issue that kind of discusses it. So if anyone's interested in that. And so let me pull up the code here and we'll take a look at this. So if we scroll over to our DNS chart and open our values, we can see that we have two installs of it. One's public DNS, one's private. I accomplished that through the dependencies. They both depend on the external DNS chart, but they actually have aliases. So we have to go ahead and tell it that to look at Istio gateways. If you enable that and Istio CRDs are not installed, things will fail, so be aware of that. And then in this case, what happens is we gotta go look at this prod YAML file. So here's the setup for the public DNS, here's the private one. You can actually make a domain filter here. The public one, associates to the public, private has the int on it. And so how this chart works is for the values here, it's going to install, so the public one installs, and when you say this Istio system, Istio public gateway, what it does is it goes and finds that gateway and finds that gateway's IP address that's on that service load balancer. And it decides that I'm going to publish that IP for everything I find. The problem is that if you don't actually filter on the domain filter, it will find both your internal and your public host names on the gateways, and it will then publish for both of them. So it ends up a situation where you don't really know what IP you're going to get. So the way we dealt with that is by manually putting in a filter. They'll take care of it. Some people had some other recommendations of how maybe to address the issue on the open problem, but I think the hope is that, you know, it'll just be solved to work like expected, and so it works like it does for all the other resources. But let's go ahead and check this out and get this installed here, so that the first thing I'm going to do is, before doing that, I'm going to take out the entries from my local host file so that we no longer have those working or affecting things. So let's go ahead and do that. All right, now if we go back, we should be able to see as well that this failed because it doesn't have the VPN like we talked about, and this application should start to fail now because it doesn't have a server IP. All right, so let's get external DNS to fix that for us. All right, so we just installed everything. As we talked about, there's actually two separate DNS charts running, one for each. And you can see that in this case, it's installed in a namespace that does not have sidecars enabled. For this, we're not really routing to it or talking to it. It kind of seemed like overkill to have Istio running, although it very easily could be turned on there. So let's see what's happening. Let's go take a look at the logs from the pod. So we're going to look at the public DNS pod first. So what actually happens here is there's a secret that's defined, and that secret was set up in Terraform, and it gives DNS access to Cloud DNS, and then by that, it's able to actually search, find the records, and publish them. So it tells you in the logs when it's adding records. In this case, you're getting your A record for your address, and that's basically what we want to be able to use. And then the next line is a text record, and the text record is used so it knows if it has control over that DNS record or not. Basically, if it matches and it's all the same, then you can change or delete the A record. If I were to delete this text record, then you can manually control that IP and it's not going to override it. So if we delete the text record and go change this to 83 in Cloud DNS, it's going to break, and external DNS is not going to publish the updated IP address. If we leave this as it is now and we delete the install and we reinstall it, when it reinstalls, it'll have the same one and it'll be able to publish that. So so now that that's published, let's see if we can actually get back to our page again. Okay, so we do have the fun thing that DNS takes a while to propagate. There's just really not much of a way around that. So like if I look up here, I can show you in the zone that we've actually got the record right now, but it's actually this one right here. It uses a wildcard. And if, let's see, I assume that this is not going to resolve locally unless it's finished up, but normally within a few minutes. Okay, good, it is. So maybe it'll let us get to our application then. Oh, I'm sorry. It, for some reason, is looking for HTTPS, which wouldn't work. Okay, there we go. So our server is running now. And let's go ahead and connect back on the VPN. And Cool. So let's see here. All right, so the next thing we want to deal with is SSL. We have an address that we can route to. Let's say that this is an auth service or maybe a Prometheus server that can show people all of the metrics from our application. Maybe we don't want that stuff readable over the internet. So basically, there's a few different ways to handle this. The most basic way is that you manually create a secret yourself, and that secret contains your cert, your key, and often a CA. And then basically you can point your gateway towards that information, kind of like is shown in this picture. It's got a private key and a server certificate it'll take, and that'll go ahead and let people, that'll go ahead and let you set it up. Obviously, manually creating certs and loading them can be a pain. So if that's the case, okay, somebody's telling me that they're having trouble hearing my audio.
I think you're back now.
Okay, sorry about that. Not sure why my internet connection is being weird. Okay, so let's see here. So yeah, with the cert manager is a chart. It's actually something that's available outside of Kubernetes even. It's part of one of their resources, but it's its own application that's in its own repo. So, and there's also a chart in the Helm repo that implements it. So the idea of the cert manager is that it's literally supposed to manage getting certificates from you via LetsEncrypt or something of that nature, and then actually saving that as a secret. So if you look over here on the right side of this picture, here's the cert manager. You're going to have two different resources that go along with it. One's an issuer. You can have an issuer, or you can also actually have a cluster issuer is another common thing that'll be used. So one issuer can be shared across the whole cluster. And then you have a certificate. And so the certificate defines, the common name and what issuer you're going to actually use. And it also has some information about what secret it's going to be saved as. And ultimately, as it gets saved down, it'll get saved as a TLS with a cert and a key here. And then when the pod actually starts here for this Istio public, that secret gets mounted. Now, the thing about this is there's actually a race condition that goes on because the cert manager takes a while to actually get a new SSL certificate, and the pod starts up before the certificate's been downloaded. So once the pod's up, it actually does not have the secret mounted. So after the certificate is finished downloading, you're going to have to actually kill this pod so that it restarts and picks up on the newest one. For this to work, this is LetsEncrypt is going to be used with a DNS challenge. And so DNS has to be publicly exposed, even for the private DNS domain. And it's just because of the type of challenge we're doing in this case. All right, so let's go ahead and try to demo some of this. All right, so I'll fire this off and then we can take a look at it. Nope, sorry, I fired that off in the wrong folder. All right, so let's go back over here. So I'll show you some about the certificate and whatnot. So in this case, we're actually keeping the certificates with our Istio chart. You can kind of see, I haven't touched on it directly, but what I ended up doing is I created a chart called Istio. And as I showed, I depend on the public Istio. So I can actually throw a few more features in here and things I want to use. One of them is the cert manager. So I said if the cert manager is enabled, then we want to create an issuer and we want to create a certificate. And we actually do two of them. So one's a public issuer. This is where I was saying you could just use one cluster issuer and get away from this. We had it set up this way for testing because you can actually control whether it's talking to a production version of LetsEncrypt or a staging version of LetsEncrypt. And so actually having that granular control when we were going through building it out was really important. We accidentally locked ourselves out of a domain. It was a test domain, so it didn't matter and we could change it. But you can get yourself locked out for a few weeks if you're not careful, and there's really no way to reach out to LetsEncrypt and have that fixed. You're just, SOL. So as you can see here, I'll look at the certificate a little bit more. Here's the secret name that it's going to get published as. Here's the issuer that it's going to use, which is just the one above. Here's the challenge for the cloud DNS, and we're actually giving it 2 different domains, and the common name we're giving it is the wildcard. So the wildcards end up working great here because I can get a wildcard cert, and I can route all of my DNS based off of the wildcard. So it just comes together where I kind of have a catch-all. And then there are some situations where you might want more specific names or things of that nature. And some of the time in those cases, I'll actually install gateways or certificates with the application or the microservice. But I always kind of have this one here to start with. Let's go ahead and see if we can see anything going on in the logs now that this is run and is completed. So first thing we want to do is let's look at the LetsEncrypt logs. All right, so looks like some stuff happened. Looks like some stuff happened for a while. Sorry, live demo, not used to quite this much information in here. I'm curious. Looks like it's still trying to get it. So you can see right here, this is where it's trying to set up a challenge. When it sets up the challenge, it actually creates a DNS record that has to propagate. So it takes some time for that to happen. Here you can see that it's trying to re-queue because it wasn't found. And this is typical that normally it'll take a minute or 2 before everything works and gets synced up. So I'll kind of show you here. This is what you're actually looking for. So, oops, let me go ahead and kill that so it doesn't move on me. But basically the certificate here, it says it got the public one and it's scheduled for renewal in blah. So LetsEncrypt, the certificates are good for 90 days. And they recommend, I believe it goes out and reaches out for a new cert. 60 days is the default. So you'll have kind of a 30-day period where you have a new cert that needs to get loaded at some point. And then up here, you can see we got the same thing for the public one. There should be something for the private one there as well, but let's just jump in and test it and see what happens. So as I discussed, we're going to have to go ahead and delete the pods. So I zero in this case, and I'm just looking at a label called charts gateway, and that covers both of the pods. So that one command just deleted my 2 pods. They probably have already come up by now, and let's just go see what happens if we try to get to our application. Okay, we hit an HTTP endpoint. It redirected us to HTTPS, and we are currently using the staging version of LetsEncrypt. So the fact that this is not a trusted cert is expected. And let's see here. All right, great. So we've still got our information back. So we know our public gateway has now loaded an SSL certificate that is usable. And let's go ahead and see about our VPN. Okay, great. This one was able to as well. So let's go ahead and look real quickly over at the code we were running. I believe that was this one. So here's actually where we're setting the LetsEncrypt. We're just setting a value, and the hyphen staging is what actually makes it publicly accessible. Yeah, and I will elaborate on killing the gateway every 60 to 90 days here in a few after I get through this demo, because there has been a solution that they've been working on for it. So I'll kind of touch on that in just a second here. All right, so So yeah, at this point, what we want to do is we've tested this, we feel pretty good about it. So let's go ahead and move to using our actual production LetsEncrypt server. So got to do a little cleanup to make that happen. So I'm going to delete the actual cert manager that's running the deployment. So now no pod will be there and it's not going to publish new secrets. I'm going to go ahead and delete the two different secrets that it had created, one for the public and one for the private gateway. And then I'm going to go ahead and upgrade or run with the new values file here. All right, so that finished. And let's go ahead and see here. Let's go look at the logs. All right, so this will kind of take a second as we know, but one thing to kind of mention here is while looking at the logs, you may think I'm weird and like, why do you actually have another call to get the pod name here and just output a metadata name? The reason is because you can actually find logs based on a label without a problem, and that's cool, but you can't do a -f where it stays open. So in order to kind of pull those things together, maybe they fixed a newer version than I'm running, but all right, so just gonna let this thing run and do its thing and kind of keep moving since we're a little short on time. Or Robert, if you want to pipe in with any questions or anything, feel free.
I think we've covered most of them except
Cool.
for the Prometheus issues.
Yeah, I'll talk a little bit about the next thing with SSL. So what's so as we were talking about, yeah, it sucks that you have to restart your pod every 60 to 90 days. I mean, you can put pod disruption policies in so that you don't really have downtime and things like that, but like why? It seems ridiculous. So they came out with this thing called SDS, Secret Discovery Service. And basically it allows you to dynamically, once a pod's already up, add and remove certificates and key pairs and things of that. It doesn't actually need to use a secret volume mount, which is good because A, the secrets are on disk, and yeah, B, for anyone who doesn't know, Kubernetes secrets are just base 64 encoded, so lock down who can get to them through RBAC as much as you can. But so SDS actually can get a certificate and it can publish it into memory into the pod. It does it by running a sidecar container that controls that. What we really wanted to do though, in that case, you have to load your own certs again. It's back to that. So really what we want is SDS to work with Cert Manager. There is still the negative side that Cert Manager stores things as a secret. So that's just going to be base 64 encoded, but it gives us the automation that we want there. So yeah, there's actually currently some information, some guides on it, like using old Kubernetes ingresses, which is a little weird. And I've put a bunch of links actually in the notes section to some of the articles I was looking up trying to get this to work. But yeah, there's an open issue on it. It's at a point where if you spend enough time, you could probably get it to happen. But like the main thing that they're talking about, it's actually missing the CA. So it can't get the full chain of trust. And it's just, yeah, the way that Cert Manager works, it doesn't publish that, but SDS is expecting it. So hopefully that'll get resolved here. All right, so let's see. It looks like, I believe this may have worked. There's a lot of information here, so it's kind of hard to tell, but let's try to hit the URL endpoints and see what happens. I'm gonna go ahead and clear my cache here. I run into lots of issues with my cache when I'm switching between LetsEncrypt and not using, or sorry, staging LetsEncrypt in production. So, yep, in this case, it still has the old one. Oh, I'm sorry, I have to restart the pods as we talked about because the pods still have the old secret loaded. So now that I hope new certs are there, let's go ahead and try deleting the pods and see if when they come up, if they have the proper cert. And let's again clear our cache. Okay, those finished deleting. This is a part of the live demo I was a little bit worried about, but worst case, I can make sure that I tell people, like I said, what was happening. My guess is like maybe the secrets didn't get cleaned up or something like that. That's the logs insert manager look a little verbose for what I'm used to seeing, but it's basically the same thing that's going to happen. It just, oh, let's see. Here we go. Now we got a renewal, so hopefully it's still spinning. Let me. Let's try killing the pods one more time and see if it comes up this time. If not, we'll just accept it. Oh, it did this time, even though I started killing them. So here you go. Connection is secure. The certificate's valid. And you can see it was issued by LetsEncrypt. So great. Everything started to work. It's, like I said, just a little flaky. All right. So I think I'm actually just going to fly through the rest of this because we're kind of running short on time. So there is some coding there, and if people want to work through the demo themselves, they can. I'll make sure it's documented well, but rather than spending the time actually doing the demo, I'll just kind of talk through the pieces. So at this point, we've got this Istio implementation. We've got private and public gateways. The main thing shared is this cert manager. Again, we could share the issuer if we wanted. And yeah, this is pretty much all the components there. So yeah, woohoo. So the next thing we want to talk about was egress. So basically the idea is that we want to control things talking outside of the cluster, and egress is the way to do that. The way that you turn on egress, you just have to follow the documentation. They've actually changed it recently. They used to enable egress by default with the chart, and they stopped enabling it by default, which pay attention to if there's something you really care about. Yeah, you might just want to hard code it yourself, or you may want to just watch the releases. But if we look here at the top, oops, this doesn't, oh, here it is, sorry. Under global, there's this outbound traffic policy. And when you add that to mode register only, it enforces an egress policy. And so at that point, you can't talk to things outside of your cluster unless you set them up specifically. So a service entry is how you set that up. And if you look here in the Istio chart, we actually have a service entry. And so you get options about how you resolve DNS. You're saying who you're talking to outside of the cluster. And so this is how the permissions are allowed for that to happen. There are a few weird things to be aware of though with service entries, and that's kind of why I at least want to touch on it. The first one being is the ports collide. So if I make a service entry with port 80 here, no other chart can have a service entry of port 80. So with that being the case, or sorry, for that gateway, so that's just, yeah, not good, because we had a bunch of situations where we're talking to MySQL databases and different guys need to talk to different people. You can still use wildcards here, so that's nice. But I guess in that case, my recommendation is that you put your service entries with the Istio chart, because they're always going to be for the whole cluster. If you're using port 80 and somebody else wants to use port 80, they have to come in here and edit the service entry. So making them live with the microservices doesn't really make sense. The other thing to be aware of is the resolution. So their documentation over here on service entries, read it very carefully if you read it. They do talk about the things, but basically this line right here, the application has to resolve DNS. So what happens is, even if you go to DNS resolve none, the application is going to try to resolve the IP address. If it can't do it, then the process fails. It's going to throw an error. If it can resolve the IP address, then Istio gets that IP address, and through different options here, you actually have the ability to override that. So you can say use a static IP I provide instead, or you can say use a DNS entry. But it's just an override. You still need to be able to get the original lookup, even if it's just a dummy address of 1.1.1.1. So like to solve that problem, in some situations, I was actually creating DNS records along with my Cloud SQL install. So then I just automatically had a mapping from my Terraform of the IP I wanted, and I could just have it leverage that IP. Wasn't the cleanest way to do it ever, but it worked. So if you look here, this values file 10 is actually going to set service entry true. And so we basically have an example that if you hit this index page and the service entry is not set up, you're going to get an error and this is going to come back empty. And that's values 9 file. If you run 10, the service entry will be set up after you Helm install Istio, and then you'll be able to get to outside resources. So yeah, that's most of it. I guess just some closing remarks here for people would be that the docs change very fast, and one-liners in the docs can be very important, so make sure you read them closely. Also pay attention to kind of what's new and what's not, because you come across something new with something old, and yeah, kind of raises eyebrows. While we've actually been running Istio, it's been really stable for us. We haven't really run into a ton of problems with it. More of our problems have been as we've been doing installs in other places, upgrading, testing things that, yeah, every once in a while, kind of like the DNS caching thing, you're dealing with a lot of things that are in flight. So having an idea of what can be cached and where things might go awry is really important. GitHub, definitely look over GitHub before you go too far. Look over the documentation first, but people are replying fairly quickly there. If they don't, hit it up again. Normally, if it's something big that's other people are going to be affected by, people will at least put a reply. I'm not saying they're going to solve it for you all the time. And then for us, I thought it was really important to start with the basics and build on it. I've found in a lot of situations, if you try to install too many pieces, it's hard to diagnose where things went wrong or what's not working well. So taking an iterative approach where you build on it's good. One of the big things we ran into was we tried to start with mutual TLS enabled, and as we were trying to add other components, it was really hard. So we just kind of decided that that wasn't a feature we needed right now. We'll back it out and we'll add it back in later. For people in general, I think it's at the point where if you want it, you can use it in production. Would I go around recommending to everyone to use it in production now? No, definitely not. For me, the biggest things that they're lacking, they don't have good CI/CD on the Helm chart. So when you get it, yeah, there's been times like pilot won't start, or times where the sidecar injector won't start for me. And those are pretty basic components that you can't even get pods to start without a sidecar injector. So yeah, but it is at a point where major companies are using it in production. So if you lock in your version and you test heavily, there are a lot of cases where it would make sense to go to production with it now. One of the things that was big for us was we were looking at either, do we go look at API gateways? Do we look at building an auth service? Or do we start with this saying, hey, well, this might not be production ready for the auth service today. It gives us a nice foundation to build on. So that was kind of the approach we decided to take, because our current auth system works fine and we don't actually need a new one tomorrow. There's a few other things. There's lots of observability that you can do. I actually installed the Prometheus operator and used an extra data source so that you can get one Grafana instead of having multiple. I left Prometheus separate for Istio because copying over all those scraping rules, I didn't have a great way to manage that. For tracing really quick, being aware that some of the docs had mentioned that tracing would be set to 100% by default, but in the Helm chart it was set a lot less. So I, for testing, bumped it to 100, but just at least be aware of the fact that you might not be catching every sample. And then as you're going to production, I still had commented out my resource limits in these values files. You should definitely comment in these resource limits. There are some weird issues in Google's cloud if you actually set a limit on the CPU. So a lot of the time we end up just setting a request for that. And then pod disruption policies are very important. The one thing that is not in here that I view as important for a production-ready Istio system would be priorities. So you'll want to make sure that you get priorities added to those so that they're less likely to fail than other things. The other thing to be aware of is just the cost. I mean, people like, everyone wants Istio and you get all these metrics and all the great stuff, but you create a ton of logs, you create a ton of metrics, you are getting a lot of traces. If you want to turn on mutual TLS, everything that's coming through, you know, you're dealing with encrypting and unencrypting. That's a lot of CPU cycles. I'm not sure like of their use case, and we're not using mutual TLS, but I even heard somebody say that like 80% of their CPU cycles at one point on a cluster were going towards, you know, Istio, which just seems ridiculous. So I think that was, I don't know if I even believe that number, but even the fact that people are throwing out large numbers, you're going to incur a cost from running Istio. There's just no way around that. So yeah, that kind of concludes things for me. I guess I'll add in real quick that at Root Level Tech we are hiring, and yeah, if anyone has any production Istio yeah, concerns, yeah, we're really interested, and yeah, so I'll kind of open up for questions here. And Robert, did you know which questions you asked already? Do you just want to keep filing them off, or do you want me to pick up?
No, absolutely. So there is still that one question about the performance issue with the Istio's bundled Prometheus. I think you kind of answered that with some of those resource limits.
Yeah, I mean, some of it's that, some of it's just you're scraping in a lot of information. If you go look at all the values that are on the default Prometheus, like, because at one point I just wanted one Prometheus and I was like looking at kind of combining those rules. It's, yeah, it's just doing a lot. I mean, a single instance of Prometheus can take in a ton of metrics, so not that it can't handle it, but if you're processing all that, there's going to be a cost associated, and yeah, very likely a performance hit too.
Awesome. And you said what? So we have another one from Artem. What information could we get from the Istio profilers? And are the profilers resource hungry?
I haven't actually jumped into the profiler, so sorry, I don't have an answer on that. As you can tell, there's kind of a lot to Istio, so our use cases have been kind of directed, but at the same time, I'm interested in a lot of other things that it can do.
Right. And we have another question here from Gahad. Is it safe to use Istio 1.05 currently available in Rancher catalog in production? I want to preface that by, before you answer and go expand on that, Braden, is they're still using that Helm chart. So there were still some problems kind of guaranteeing that version, as Braden talked about earlier, which is why he copied down the repo and cloned it to make sure that there weren't any upgrades that were just auto-magically happening without his knowledge.
But along those lines, I guess my recommendation would be like, to either thoroughly test the install that you're using that's a custom install, or try to go with something that's being provided, because of the fact that hopefully they'll be testing as they release new ones more thoroughly than you would. So, but yeah, there's just a trade-off there on how much control you have over the install versus getting something that's been more tested and more vetted.
And within Rancher, you can clone those repos and make your own custom catalog as well.
Cool.
So you might want to do that, Jihad, just so you have a little more control over, you know, your versions.
Yep.
And I think that's all the questions I see here.
Oh, cool. Well, yeah, thanks everyone for your time. Yeah, sorry that I didn't have a chance to demo the service entry stuff, but like I said, I'll make sure that the repo has all that stuff in there so that you can play with it yourself. Bye, guys.
Thanks, everyone.